Hello friends. Welcome to Defense Matrix. On this channel you will get fully information about defense and technology. Let's view the video. How the Boeing 787 works. Inside the cockpit, advanced avionics flight systems of the 787. The cockpit of the Boeing 787 Dreamliner isn't just a pilot's workspace, it's a futuristic control center that represents decades of cutting-edge technological evolution. Unlike traditional analog cockpits, the 787 features 5 large LCD displays, each customizable and multifunctional. These aren't just screens, they are command centers, allowing pilots to control everything from flight paths to weather radar, terrain mapping, and engine performance all in real time. The fly-by-wire system replaces conventional manual flight controls with an electronic interface, allowing the aircraft to make precise adjustments automatically. This kind of system is usually seen in military jets, but Boeing brought it into commercial aviation, giving the Dreamliner military-grade responsiveness and safety. The head-up display, HUD, is another game-changer. Projecting key flight data right onto a transparent screen in front of the pilot's eyes, it lets them keep their head up and eyes forward, crucial during bad weather or night operations. These systems are often reserved for fighter jets, but the 787 has it. Every part of the cockpit is designed with automation, safety, and efficiency in mind. From automated checklists to real-time system diagnostics, the Dreamliner doesn't just assist pilots, it thinks with them. And for defense enthusiasts, here's the kicker: much of this cockpit tech is shared DNA with military aircraft like the F-22 and the E-7 Wedgetail. This isn't just a plane, it's a flying computer. And understanding the cockpit is the first step to appreciating how the Boeing 787 is rewriting aviation norms. The power within, GE versus Rolls-Royce engines that drive the Dreamliner. What really makes the Boeing 787 soar isn't just its design, it's the engines that power it through the skies. The Dreamliner comes with 2 power plant options, the General Electric GEnx and the Rolls-Royce Trent 1000. Both are masterpieces of engineering and push the boundaries of modern propulsion systems. Let's start with the GEnx. It's built with the same carbon fiber composite fan blades found in military drones and bombers, making it lightweight yet incredibly durable. It offers 15% more fuel efficiency than previous generation engines and emits significantly fewer greenhouse gases. This matters in both commercial savings and defense logistics, especially when you think about refueling and long-range capabilities. On the other hand, the Rolls-Royce Trent 1000 is a true powerhouse. Known for its low noise levels and high thrust-to-weight ratio, it's designed to perform efficiently across long-haul missions. And here's the kicker: the Trent family of engines also powers many military aircraft, giving the 787 military-grade reliability. These engines aren't just about raw power, they're smart. Both options use onboard sensors to monitor performance in real time, sending data back to ground teams. This predictive maintenance is straight out of the military's playbook, ensuring aircraft stay mission-ready without unexpected breakdowns. But perhaps the most fascinating part? These engines can run for over 1,000 flight hours between maintenance checks, making the Boeing 787 one of the most self-sufficient aircraft in the sky. So whether it's GE or Rolls-Royce, the Dreamliner's engines aren't just efficient, they're engineered for performance, precision, and global readiness. Stealth by design? Composite materials aerodynamics explained. When people hear stealth, they usually think of military jets like the F-35 or B-2 Spirit. But the Boeing 787, while not a stealth aircraft, shares surprising design similarities that make it more efficient, more aerodynamic, and harder to detect by radar than traditional airliners. One of the biggest innovations is the use of composite materials, primarily carbon fiber reinforced polymer. More than 50% of the aircraft's structure is made from these advanced composites, reducing weight dramatically while increasing strength. This isn't just smart, it's strategic. Lighter aircraft mean less fuel burn, longer range, and fewer emissions. But composites also absorb radar waves better than metals, making the aircraft less visible to radar in certain conditions. This is a byproduct benefit, not a defense intention, but it's worth noting for those interested in dual-use technology. Now let's talk about aerodynamics. The 787's wings aren't just beautiful, they're functional. With a curved, raked wingtip design, they reduce drag and increase lift. These aerodynamic features are inspired by fighter jets and stealth bombers, which use similar shapes to maximize performance while minimizing radar cross-section. Even the smooth, seamless body of the 787 helps with both fuel efficiency and acoustic stealth. No protruding rivets. No excess joints. Everything is flush and smooth, reducing air resistance and making the aircraft whisper quiet in the skies. This kind of engineering isn't just for comfort, it's for performance. And while the Boeing 787 may not be dropping bombs or dodging missiles, the tech behind its materials and aerodynamics is undeniably defense-inspired. Smart cabin, smart systems, how the 787 revolutionized airborne technology. When you board the Boeing 787, you're not just stepping into a plane, you're stepping into a flying technological ecosystem. This aircraft isn't just smart in the cockpit, its entire cabin is intelligent, connected, and built to respond to both human comfort and system efficiency, making it one of the most advanced commercial jets ever created. Let's begin with the cabin pressure system. Unlike older jets, the 787 maintains cabin pressure equivalent to 6,000 feet above sea level, significantly lower than the usual 8,000 feet. What does that mean? Less fatigue, fewer headaches, and more oxygen for passengers and crew. This feature was originally inspired by military transport aircraft, where maintaining soldier stamina on long missions is critical. The air filtration system is another standout feature. Using HEPA and gaseous filtration, the 787 removes odors, allergens, and 99.97% of airborne particles. It's like a clean room at 40,000 feet, ideal not just for passengers, but also a potential blueprint for future defense medevac aircraft or military command flights. Next, the electronic dimmable windows, no shades needed. A touch of a button tints or clears the window in seconds. This tech uses electrochromic materials, the same kind of adaptive tech seen in advanced combat helmets and stealth vehicle glass. The smart lighting system mimics natural light cycles to help passengers adjust to different time zones. This reduces jet lag and enhances crew alertness, a crucial feature for long-haul missions or rapid deployment operations in the military world. And behind the scenes, the 787's onboard health monitoring systems continuously scan for faults, or system abnormalities. If something's off, ground teams know before the aircraft even lands. This predictive maintenance strategy is adapted directly from defense aircraft logistics, where mission readiness can't wait. In short, the Boeing 787 doesn't just fly. It thinks, adjusts, and protects, and that's why it's changing not just civilian flight, but the future of military aviation, too. From factory to flight, the global supply chain behind the 787, the Boeing 787 isn't built in one place, it's assembled across the world in a globally synchronized defense-grade supply chain. Parts come from over 10 countries, with wings built in Japan, fuselage sections in Italy, and engines crafted in the UK and the US. This global cooperation reflects a military-style logistics operation, designed for precision and efficiency. Every component is scanned, tracked, and transported using military-level RFID systems and AI logistics management. Final assembly happens in Everett, Washington, where robotic systems ensure millimeter-perfect alignment. This isn't just manufacturing, it's orchestration on a global scale. What makes this important? In times of crisis, the same logistics model could be applied to military aircraft production, emergency transport planes, or strategic global deployments. The Dreamliner isn't just a marvel of aviation, it's a lesson in how global defense collaboration can build the future of flight. Thanks for watching. Subscribe our channel Defense Matrix for more interesting and knowledgeful videos.